Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. Let me just check. Yeah, so here's my profile. Uh, I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants. Yeah. So I have been mentoring IIT-JEE aspirants for last 11 years. So I teach mathematics, and we were doing AOD. So this is I've already taken 10, 11 sessions of AOD, and today we'll discuss the graphs based and concavity of functions. Maxima, minima, monotonicity is already covered in previous sessions. So before we begin, let me tell you about the Unacademy subscription. As you know, Unacademy is India's largest online learning platform. And once you are subscribed to IIT-JEE, if you're preparing for IIT-JEE, then you can have two types of subscriptions on Unacademy. One is Plus subscription, another is Iconic subscription. Okay, so for Plus subscription, you get unlimited access to daily live classes of all the educators who are teaching for IIT-JEE. You can watch their recorded lectures also if you miss something. And this is unlimited access. That means you can watch anybody's live sessions. So courses are going on Academy's platform. You can join anyone's course, educator of your choice. There is complete freedom. You have all the live tests and quizzes also you'll get. And these courses are well structured. Everything is pre-planned, so you can see the all the upcoming lectures in well advance. Now these are the subscription charges. So you can subscribe for 1, 3, 6, 12 and 24 months. For 12 months it is 38,500, and for 24 months it is 56,000. And you get 10% discount also in these codes using the referral code Jeet1. You can use this code and you'll get 10% discount. This is the Iconic subscription. In Iconic subscription, you get a personal coach. Okay, and test analysis also done in a personalized manner. And all the benefits of Plus you will get in this Iconic subscription. Apart from that, you are getting a personal coach. Okay, and a test analysis is done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be customized. Weekly reviews will be given to you. All right. So all these additional things you'll get once you have Iconic subscription. Now we can see you can subscribe for 12 months or 24 months accordingly. If 12 months it is 56,000, for 24 months it is 86,000. All right, and you get 10% discount. So finally you have to pay 50,400 and 77,400 using the same code Jeet1 you can use. All right, and this is Unacademy's learning app which you can download from Play Store. All right, and you can start attending special classes. Now first I'll tell you about the concavity, and then we will begin graphs. Just a moment. All right. Concavity. So if graph is like this, graph of a function is like this, then it is called concave up. Concave up means if f is a second differentiable, twice differentiable function, twice differentiable function. Okay, if f(x) is a twice differentiable function and f double dash x is more than 0, all right, then graph of f will be concave up. Let me explain it. So if f double dash x is more than 0, that means f dash x is increasing, right? So if f dash x is increasing, but we are not commenting on f. F can be increasing or f can be decreasing, okay? So if it is if graph is like this, then see f dash, that means slope will be increasing in this graph, okay? If you check the slope at this point, then slope is like this, right? Slope is some tan of this angle. Now if you go ahead and for greater value of x, if you check the slope, then slope is going to increase now. So now you can say this theta is increased. Now theta is increasing, so tan theta will also be increasing because tan theta is an increasing function, right? Now further you can check for some other point. You can further check that again slope has increased, right? So this angle has increased, that means slope has increased. So in this graph you can see tan theta is increasing, that means tan theta is increasing. Tan theta means f dash is increasing, okay? So if graph is increasing, then it will be increased like this. Increasing graphs can be of 3 types, like this, like straight line, and like this. Graph can increase, graph of f can increase in 3 ways. This we have just seen. Then this, if graph increases like this, that means slope is increasing. If graph is increasing, in this you can say f dash is increasing. In this graph you can see f dash is a constant. F dash is a constant, right? And in the other one, this one, you can see slope is decreasing, right? You can see in this slope is decreasing. The slope is decreasing, that means f dash x is decreasing in this graph, right? So if slope is decreasing, that means f double dash is less than 0. So if f double dash is less than 0, then it will be decreasing. Now, similarly, graph can decrease in 3 ways. Graph can decrease like this, graph can decrease like this, or graph can decrease like this, all right? So if graph is decreasing, say this is the first case, this is the second case, and this is the third case, okay? So in first case, let's see what will happen to slope. So if you can see, this is the slope for some x, okay? This is x-axis. So if you go ahead, you can see slope is increasing because theta is increasing. This is the theta with x-axis. This is the theta. So theta has increased. Theta has increased. That means tan theta will increase, right? Now again, you can see this angle is increasing with x-axis, all right? So in this graph, when graph is f is decreasing, you can see f is decreasing, but f dash is still increasing. Slope is still increasing, okay? So if function, that means f decreases like this and increases like this, okay? In both the cases, you can see f dash is increasing, okay? You can see f is decreasing here, right? And f is increasing here. So there's no relation of f. F can increase or decrease in concave up. But f dash, you can see, is always increasing throughout this process. When f was decreasing and when f was increasing. In this whole graph, f dash was always increasing, okay? So when f dash was always increasing, that means f double dash was positive because f dash is increasing. So its derivative will be positive. So if f double dash is positive, then graph will be like this, which I have drawn in the beginning, okay? So this is called concave up. This graph is called concave up. So whenever we know that f double dash is positive, that means graph will be concave up. Now graph of f might decrease or increase. That we will check through f dash, if f dash is positive or negative. All right, we have already done that. So if f dash is positive or negative, we can comment on the increasing or decreasing part of f. But if f double dash is positive, then which type of increasing will it be and which type of decreasing will it be, right? We can comment on that. So it will be of this type, right? Now let's discuss concave down also. This was concave up, and this graph is concave down. We have already seen. Now let me show you in this whole graph. So if f double dash is, again f is a twice differentiable function, and f double dash is less than 0, that means graph of y is equal to f. Second derivative, we are checking the second derivative. Now we are plotting the graph of y is equal to f. Will be concave down. Concave down. And again, we are not commenting whether f is increasing or decreasing, right? It can increase. You can see it can increase or it can decrease also, right? Now let me show you that f dash will always decrease. Slope will always decrease in this case. So you can see the slope here. If you draw a tangent, you can see this is the angle. Now draw a tangent some other point, which is on the right side of the previous point. So now you can see this angle has decreased, right? Further, if you go forward, then this angle is further decreased, right? So you can see this angle is decreasing. That means tan theta is decreasing. So that means f dash, tan theta is f dash. So f dash is decreasing. In this part, you can check here also. This is the slope. This is the angle, right? Now further, if you see, the angle has decreased with positive direction of x-axis. Further, you see this angle is further decreased, right? So angle is decreasing. That means tan theta is decreasing. So f dash x is overall decreasing in this graph, right? So when f is concave down, then its graph will look like this, right? Graph will look like this. Is that okay? So this is called concave down. Concave down graph. And again, we are not commenting on f. F can increase or decrease. So I hope this is clear now. Now further, let's check the concavity of some functions. So if I check the, I'm giving you very easy examples. Y is equal to sine x, right? We already know the graph graph of y is equal to sine x. Let's check it. So if you see, if I find example 1, y dash x is cos x, and if I find y double dash, it is going to be minus sine x, right? Minus sine x. So if you plot it, then you can see f double dash is less than 0, right? F double dash is less than 0 when x belongs to 0 to pi. Let's plot it in 0 to 2 pi, okay? And greater than 0 when x belongs to pi to 2 pi, because sine x is negative, so minus of sine x will be positive. So graph will be concave down in 0 to pi, right? So that's why we plot like this. 0 to pi, you can see concave down, and then concave up in pi to 2 pi. So that is the graph, right? It's very simple, very easy to understand. Now suppose if I give you this example, y is equal to x cube, right? You already know the graph of this. So y dash, is 3x square, which is always positive. That means y is always increasing. But which way it will increase? Which type of increase? I mean, it will increase like this or like this. Let's see. So if I find y double dash, it is going to be 6x. That means y double dash is positive. Y double dash is positive when x is positive, and y double dash is negative when x is negative. That means when you're plotting the graph of this function, then this will increase, then it will be concave down. It is always increasing. We know that, right? It is always increasing. So y is always increasing. But it is concave down when x is negative. At x is equal to 0, value is 0. So it will cross 0, 0 at this point. And then it is concave up. That's why we plot like this, right? Then it is concave up. So this is the graph. So I hope it is clear, huh? I'll give you one more example. Now suppose you are plotting the graph of y is equal to x raised to, say, 3 by 5, okay? Take any example like this, 3 by 5. So domain is R, x belongs to R, right? Now let's slowly understand how do we actually plot the graph using this calculus. So first of all, we have written the domain. Okay, first of all, we have written the domain. Now we can see this function is an odd function, right? So it will be symmetric about origin. That's one thing. Second, when x approaches to infinity, it will be plus infinity, and x approaches to minus infinity, it will be minus infinity. That means graph will start from minus infinity and it will go up to plus infinity, right? And it's a continuous graph. Now, whether it is increasing or decreasing, or which part it is increasing, I mean in which interval it is increasing, to find that we need y double dash. So if I differentiate it, I'll get 3 by 5 x raised to minus 2 by 5, right? 3 by 5 minus 1 is minus 2 by 5. So clearly you can see 2 by 5 will make it positive. So y double dash is always positive, right? That means y is always increasing. This is a positive number because of this 2 power, okay? Obviously you can take it to the denominator, but still it will remain positive. Now let's find y double dash. So if you find y double dash, it is going to be minus 6 upon 25, okay? And then x raised to minus 2 by 5 minus 1. So it is going to be minus 7 by 5, okay? Minus 7 by 5, you can write like this, minus of 6 by 25 x raised to 7 by 5, right? Like this. Now you can see this, because 7 and 5 both are odd. So you have odd upon odd, x raised to. So it will be positive. It will be positive for positive x. But because of this minus, sign will be different. So it is negative. It is concave down. So you can see this y-axis is actually tangent to this curve, because this graph is vertical. You can see derivative of this function is not defined at 0. That means it has a vertical tangent. So this graph has a vertical tangent. Okay. So this is the graph. I hope you have understood. You can see y double dash is less than 0 and y double dash is greater than 0, right? This is the point where concavity is changing, okay? The point where function changes its concavity. The point where function changes its concavity is called point of inflection. Point of inflection. So now I'll tell you the point of inflection first. So point in the domain of f, make sure, where function changes its concavity is called point of inflection. Like graph is going like this, and now after this point it becomes like this. That means this is the point where function is changing its concavity. So this is x is equal to a. And then this point is called point of inflection. Point of inflection. I hope you understood, huh? Like in case of sin x, you'll have to do some calculation to find that. I am telling you the calculation. This is the point. Pi is the point where sin x is changing its concavity. Okay, pi. I'll tell you how to find it. There's a standard procedure for differentiable functions. Okay, so how to find the point of inflection? Now that is the point. So if function all right, it's twice differentiable, or maybe if function is, let me write it in another way. So it's a continuous function. So if at x is equal to a, f double dash x is either 0 or f double dash a, let me say f double dash a, is either 0 or not defined. But A is in the domain. But where A is in the domain. That I have written in the definition also. So if at x is equal to a, f double dash is 0 or not defined, first condition is this, then further and f double dash x changes its sign, like it becomes positive to negative or negative to positive, like we have done in monotonicity also when function was differentiable. So changes its sign about x is equal to a, then x is equal to a, then x is equal to a is called point of inflection. Then x is equal to a is called point of inflection. Alright, so I hope it is clear. Zian Malik, hello. Sorry. Let me give you one example, like y is equal to x cube only. Y is equal to x cube. You know y dash is equal to 3x square and y double dash is equal to 6x. Now you can see this is equal to 0 when x is equal to 0, right? So x is equal to 0 might be point of inflection. What you need to check is at x is equal to 0, f double dash is 0. After 0, f double dash is positive, and before 0, f double dash is negative. So yes, it is changing its sign. So yes, this point is point of inflection. That means x is equal to 0 is point of inflection. And we know the graph. So we know the graph also. So we know that yes, that is the point of inflection. Concavity changes at this point. Okay. So this was pretty simple. We were trying to understand this calculation. Now let me give you another example. If you have y is equal to x raised to 1 by 3, okay? Now let's see what happens. So domain of this function is also R, right? We have seen the graph of x is equal to 3 by 5 and graph of x raised to 1 by 5, 1 by 3 will be similar to that. Let's find the point of inflection. So if I differentiate, y dash is going to be 1 by 3, x raised to minus 2 by 3. There is phi dash. Now further differentiate, so y double dash is going to be minus 2 by 9, x raised to, it is now minus 2 by 3 minus 1, so it is minus 5 by 3, okay? Now you can see, at x is equal to 0, derivative is not defined, but 0 is in the domain, right? So at x is equal to 0, y double dash is not defined. It's alright. Point should be in the domain, and y double dash might be 0 or might not be defined. Two cases are there, right? Apart from that, you know, y double dash is changing its sign. So at this point, at x is equal to 0, y double dash is not defined. And after that, you can see this is a positive number when x is positive and negative number when x is negative. And because of this minus sign will change. So when x is more than 0, you can see it is negative, y double dash is negative, and it is positive, y double dash is positive, and x is less than 0. So yes, you can see y double dash is changing its sign. Y double dash is changing its sign about x is equal to 0, and it is not defined at x is equal to 0. It's alright. So now you know the graph of this function is like this. It is concave up. So you know that at x is equal to 0, there was a vertical tangent. So y dash was not defined, and because of that, y double dash is also not defined. When it is not, first derivative is not defined, then obviously second derivative will not be defined, but function is defined, okay? That is an important point. That's why we are including this point in our inflection point. This is point of inflection. So x is equal to 0 is point of inflection in this case also. So I hope you understood this. Now, Now I'm giving you one graph to plot. Let's plot y is equal to x with all the x raised to x with all the information. Okay, we need to check its domain, range, and so first I'll tell you the steps to draw the graph. First is write the domain. So you should know, in which interval you need to plot the graph, first of all. Okay. Second is write the values or limits at the endpoints. So if interval of domain is open interval, then you can write the limits at the endpoints. If interval is closed interval, then you can write the values at the endpoints. So we will know that we are starting from this point and we'll end at this point. Okay, if we know the coordinates of endpoints. Now in between, what will happen that we will discuss through y dash and y double dash. So third point, before knowing that function is increasing or decreasing, first we'll try to check if there is any symmetry or periodicity. If the function is periodic, then we'll draw the graph of that function in one interval, and after that it will repeat its values, right? So it will repeat its graph also. If there is any symmetry, like function is even, then it will be symmetric about y-axis. If function is odd, then it will be symmetric about origin, right? So that kind of symmetry also we can use. Fourth, so this is something which may or may not happen. Like functions might be symmetric about some line or point, or function might not be symmetric. It might be periodic, it might not be periodic. So this is something which, if it is there, then it's a good point. It will help us in drawing the graph. And if it is not there, then also it's all right. Always checking my voice. Now, next point is check the monotonicity. Check the monotonicity. All right. So we'll check the monotonicity by finding the f dash. So f dash is positive or negative. Accordingly, graph will be increasing. Graph of f will be increasing or decreasing, right? We know that. Now next point is going to be, now we know f double dash. Okay. So we'll check the concavity. So check the concavity. So if you know that graph is increasing or decreasing, then further to plot the accurate graph, you should know how would it increase. Will it be concave up or will it be concave down? So that is an important point to know. Like in x cube, first it was concave down and then it was concave up, right? So it was like this and then it was like this. If we know that it is increasing, then there are many ways to plot it. You can plot like this also, only concave up. You can plot like this also, only concave down. You can plot like this also, first concave down and then concave up, right? And then you can plot like this also, concave up, concave down, concave up, concave down, concave up, concave down, right? Like this also. So now concavity becomes an important point if you want to draw the accurate graph. Okay, so that will give you f double dash, positive and negative. So accordingly, f dash will be increasing or decreasing, and that means concave up or concave down. So these are the steps you need to check. So I'll give you one example and then we'll plot it. So let's plot the graph of a very simple function x plus 1 upon x. Okay. Further, if you want to draw a more accurate graph, then you should know asymptotes also. Asymptotes. But because we are not discussing the asymptotes, I'm just skipping that part. So let's stick to up to concavity. All right. Because if I include asymptotes, then first we'll have to understand asymptotes, horizontal, vertical, and oblique asymptotes. And after that, we will be able to plot. So some graphs may have asymptotes, vertical or horizontal or oblique, or they might not have. So just ignore the asymptote part first as of now, and then plot the graph. Okay. Although this function has two asymptotes, one vertical and one oblique. So I'll tell you about that. Try to plot it. You do it yourself, and I'll discuss with you. Try to plot it. You do it yourself, and I'll discuss with you. All right, so let's plot the graph. Sorry, this function. So first, we'll see this function. First of all, we'll write the domain. So domain you can see is r minus 0. All right. So 0 is not there in the domain. Otherwise, all the points. Second, we'll write the end point limits. So endpoints you can see interval is minus infinity to 0, union 0 to infinity, right? So endpoints are minus infinity and 0 minus and 0 plus. And okay, so why when x approaches to minus infinity? You see this is minus infinity and this will be 0, as simple as that. So it is minus infinity only. When x approaches to plus infinity, when x approaches to plus infinity, then function is going to be plus infinity and then plus 0. So it is plus infinity. But when x approaches to 0 minus, then what will happen? See, when x approaches to 0 minus, then 1 upon x is minus infinity, and x will be 0 only. So it is minus infinity, right? and when x approaches to 0 plus, that means positive side of 0, then 1 upon x will be plus infinity and x will be 0. So y will approach to plus infinity. So you can see all the end points, whether it is 0, left side of 0, right side of 0, or plus infinity or minus infinity, function is approaching to either plus infinity or minus infinity. All right. Third is, I told you about the symmetry. So yes, this function f, if I call it f, then f is an odd function. Odd function, that means symmetric about origin. All right, symmetric about origin. Fourth, we'll draw f dash. So f dash is equal to 1 minus 1 upon x square. So if I simplify it, it is x minus 1, then x plus 1, then divided by x square. If you plot the sign, you can see f dash is positive here, 1 and minus 1, then negative and then positive. 0 pe there is no change of sign because of x square, so only I have plotted only two critical points. These factors which have odd power, okay? So it is decreasing in minus infinity to minus 1, and then it is, increasing. And then it is decreasing from minus 1 to 1, and of course there will be discontinuity at 0. And then after 1, it is again increasing, all right? So that is going to happen, yeah? Now, which way it will increase or decrease? So for that, you need f double dash. So f double dash is going to be differentiated. It is further differentiated, and then it's going to be plus 2 upon x cube, right? Which you can see is positive when x is positive and negative when x is negative, f double dash. So it is concave up here and concave down here, right? So we have got enough information to plot the graph of this function. All right, so now see, it is coming from minus infinity and it's concave down, and first it is increasing up to minus 1. So minus infinity to minus 1 is like this. Let me plot some more correct graph. All right, so it is coming like this, increasing concave down. Then 1 at minus 1, it is going to have a maxima, local maxima, because after this it is going to decrease. So it will decrease, and when x approaches to 0 minus, it is going to minus infinity, right? So it will become parallel to this line. So you can see this parallel line. So if a vertical line is parallel to the graph, then this vertical line becomes vertical asymptote, okay? Then after 0 plus, if this plus infinity, graph will be concave up. First it will be decreasing up to 1. You can see all these data I have already mentioned. Then after 1, it is going to increase. So it will increase like this. So it is going to increase like this, okay? Like this. I'm making it a straight line because I know that this line, this vertical tangent is a vertical asymptote, and this line also has a oblique, this graph also has an oblique asymptote, okay? And that asymptote is this y is equal to x line. It is parallel to this y is equal to x line, okay? This is an additional information I am adding here. Simply I can explain that you can see it is x plus something, okay? So when x is positive, then it will be above the y is equal to x line. But when x is approaching to infinity, you can see it will be very close to y is equal to x line, because this part is going to 0 when x approaches to infinity. So it is x plus very small number. So it's close to y is equal to x line. This is one of the way to explain it, but not the proper method to find oblique asymptote. There's a proper method to find oblique asymptote. Okay, you can take fx minus mx plus c function, a line, and when x approaches to infinity, this difference should approach to 0. In that way, you try to find m and c, and you get, if you get m and c, then you get oblique asymptote. So anyways, I'm not discussing oblique asymptote today. I'll discuss up to this part. Now the second graph we need to plot is this: y is equal to x raised to x, accurate graph. Okay, example 2. So let's plot it. Was limit at the end point. So r plus means 0 to infinity, right? So we need limits at 0 and infinity. So when x approaches to 0, x raised to x approaches to 1. We already know the limit, right? And when x approaches to infinity, and x raised to x will approach to infinity. That means graph will start from 1 and it will go up to infinity. Okay. Now what will happen in between? It will increase degrees. Let's check. Is there any symmetry? Even, odd, periodicity? No. This function is, it cannot be symmetric about y-axis or origin. Odd and even, there's no point because domain is only 0 to infinity, right? And obviously same for the periodicity also. Third is, so we'll immediately jump to y dash, and if we differentiate, if you know the differentiation, x raised to x, it is 1 plus ln x. Okay, you know how to take it. I have already done this question before in maxima and minima, right? So I've explained how to differentiate it. Now you can see this function was, this point is 1 upon e, so it was plus positive here and negative here. So 0 to 1 upon e, it is decreasing, first decreasing and then it is increasing, right? Now which way it will increase or decrease, we need to find double dash x. So this is the sign of f dash, and this will be the graph of f, increasing, decreasing, decreasing, and then increasing after 1 upon e. So if I find y double dash, it is going to be x raised to x 1 plus ln x the whole square plus x raised to x into differentiation of 1 plus ln x is 1 upon x. All right. Now you can see this is a positive number and this is also a positive number, right? So that means it is always positive. So y double dash is always positive for all x belonging to 0 to infinity. That means graph is going to be concave up only, right? Simple. So this is pretty simple. If I start plotting the graph, that is going to be like this. first it will start from 1, but 1 is not closed. It will decrease up to this point, which is x is equal to 1 upon e, and after this point it will increase, and yes, of course, values will be positive. So now we can write the range of this function also. The minimum value, least value we know is, if you put 1 upon e, it is 1 upon e raised to 1 upon e, or you can write e raised to minus 1 upon e. It's a positive value, of course, so it will be somewhere here. And from this point to infinity is the range. If you want to write the range, you can write the range easily. Range is e raised to minus 1 upon e to infinity. Okay, so you can answer many questions related to this. If I ask you, if I frame just now one question, if x raised to x is equal to k has two solutions, then find k. All right, k is a constant. So you know, if I plot a line like this, if I plot a line y is equal to k line, we need to plot, to see the number of solutions, you need to plot y is equal to x raised to x, which we have already plotted, and then y is equal to k. So y is equal to k line is a horizontal line. If you plot it, it will cut the graph y is equal to x raised to x only at once, right? Simple. Now if you plot a graph line below 1 and above e raised to minus 1 upon e, if k lies between these 2 points, this and this, okay, then it will cut the graph at exactly 2 points. You can see that, right? So for two solutions, your k should be greater than e raised to minus 1 upon e, and of course it should be less than 1. That is the answer. Alright, let's plot one more graph. Four x cube, okay? There's a simple graph. Let's plot it. You want to check in this, I want you to check points of inflection and concavity. Basically, for that only I have given this. You can see it's a polynomial. So fourth degree, you already know it should be like this, right? Or maybe like this, okay? So you need to focus on the points of inflection, okay, and maxima and minima. That is an important point for this question. So try this for a minute, then I'll tell you. Then we will discuss. Plot the graph. Alright, so let's begin. First we'll write the domain. So domain is of course R, right? Second, endpoints when x approaches to plus minus infinity, both sides y will approach to only infinity, okay? So it will come from plus infinity and will go to plus infinity. What will happen in between, that is the main point, okay? Now third is there's no symmetry. This function is neither even nor odd, it's not periodic. So we'll immediately jump to y dash. Y dash is 12x cubed minus 12x square. So you can take 12x square common and it will be x minus 12. So you can see y dash will change its sign only after 12. Oh, sorry, it is 1. This point is 1. This point is 1. So it is positive and negative, and this point is 1, okay? And fourth point is, if I check y double dash, then that is going to be 12, you can take common, it is 3x square minus 2x. And further you can take x common, so it is going to be 3x minus 2. And now you can see there are 2 points where y double dash is 0 and it will change its sign also. One point is 0 and the point is 2.2 by 3, plus minus plus. So these 2 points are points of inflection, because y double dash is 0 as well as it is changing its sign about these points, right? Now let's plot it. The graph is going to be interesting. So you can see it is coming from plus infinity and it is concave up to 0 and 0 पे इसकी value भी 0 है. So it will meet the x-axis at 0. Now you can see concavity is going to change. So at this point concavity will change, but function will keep decreasing. It will decrease up to 1. So it will keep decreasing, decreasing, concave down. And then concavity will change again at which point? At 2 by 3. So 2 by 3 is somewhere here. Now it is going to be concave up, okay? And it will become like this. After 1, you can see it is going to be increasing graph. Y is going to be increasing. And which way it will increase? It is going to be concave up now. After this, there is no change in concavity. Only it will become monotonically increasing from decreasing when it crosses 1. Okay, so it will be like this. Okay, it will be like this. Alright, so this is the graph. You can see 2 points of inflections are there, 0 and 2 by 3. And this is the point where it is changing its monotonicity. There's the least value, right? You can write the range of this function also. So range, you can write range is going to be f of 1 to infinity. And what is f of 1, by the way? Put 1 in the equation. So you're going to get 3 minus 4 is minus 1 to infinity. All right, I guess. Now, okay, so you've got range, everything you can answer now, everything. Like if I give you one question, 3x raised to 4 minus 4x cubed is equal to k has 2 real and 2 distinct solutions. Then find k. Find k. So now you know you have already plotted this curve. Now you need to plot y is equal to k line and see what will be k so that it will cut the graph only at 2 points. This is going up plus infinity. So if you plot y is equal to k line here, obviously of course it will cut at 2 points. Even if you plot graph y is equal to k line here, it will also cut at 2 points. right? Even here it will cut at 2 points, but if you draw here, it will not meet the function, right? So that means k should be more than this point, which was the minimum, -1, so -1. So if k is more than -1, if k is more than -1, then they will meet at 2 distinct points. So I suppose it is clear. Okay, so one last question. Now let's plot y is equal to x raised to 1 by 3 into x minus 1. Okay, we'll plot this. So try this for a minute, then we will discuss. Alright, so let's begin. So first of all, let's write the domain. So this is defined for all real. This is also defined for all real. So x belongs to R is the domain. First point, we have got domain. Second, we are going to see the limits for x approaching to plus infinity and minus infinity. So x approaching to minus infinity, this is minus infinity, this is also minus infinity. So when x approaching to minus infinity, y will approach to plus infinity. When x approaches to plus infinity, then of course y will approach to plus infinity only. Now third point is y dash differentiated. So first you can write this in this form, x raised to 4 by 3 minus x raised to 1 by 3. Now it's easy to differentiate. So 4 by 3 x raised to 1 by 3 and minus 1 by 3 x raised to minus 2 by 3. Alright. If you take LCM, it is going to be 1 by 3, 4x minus 1 divided by x raised to 2 by 3. We plot the sign. This is the critical point, which is 1 by 4. Denominator is always positive. This is always positive. So only numerator will change its sign about 1 by 4, positive to negative. An overall function will also change its sign like this, plus to minus. So this is y dash negative, this is y dash positive. First it is decreasing, then it is increasing. After 1 by 4, it is increasing. Now let's check y double dash. Y double dash. So y double dash is further differentiated. So it is 4 by 9 x raised to minus 2 by 3 and plus 2 by 9 x raised to minus 5 by 3, right? Now further, if you take LCM and take common, this is 2 by 9 common, and is 2 upon x raised to 2 by 3. First let me write like this, plus 1 upon x raised to 5 by 3. So if you take LCM, it is going to be 2 by 9 x raised to if you multiply it, it's going to be 7 by 3, right? and it is x raised to 5 by 3 minus plus x raised to 2 by 3. And of course, you can take x raised to 2 by 3 commons. Basically, finally, you can write like this. I should have written it earlier. 2 by 9 and 2 times of x raised to 2 by 3 plus 1. Sorry, x raised to 1. This is x raised to 1. 2x plus 1 divided by x raised to 5 by 3. So it will change its sign at 2 points. Denominator is also has critical point 0 and numerator has critical point minus 1 by 2. So minus 1 by 2 and 0. So two critical points, plus minus plus. Alright. Concave, concave up, concave down, concave up. Alright, like this. Now let's plot it. So we plot the graph. So first it is coming from plus infinity, as you know, and it is concave up, so it will be decreasing and concave up. So like this, up to which point is this? It is decreasing 1 by 4. So it will keep decreasing, concave up, then it will become concave down after minus 1 by 2. After minus 1 by 2, it is going to be concave down. Yeah, of course, you can plot the sign of y also. 1, 0, so plus, minus, plus. Graph will be above the x-axis. So now it is going to be like this, and 0 is another point of inflection, so it will become concave up again, but still decreasing up to 1 by 4, so this is 1 by 4. Okay, all right, and after 0 it is always concave up, and after 1 by 4 it is now increasing, so it will increase like this, and at 1 it will become positive, and this is the exact graph. Okay, so this is the graph. I hope you're understanding. So what is this point, by the way? You can put 1 by 4 in the given equation, so it is going to be minus 3 by 4 into 1 by 4 cube root of 1 by 4. Okay, so 1 by 4 raised to 1 by 3, like this you can write this point. Okay, and then further you can make some questions like, so this has two inflection points, one point of extrema, local extrema, which is minima at 1 by 4, and you know where is this function decreasing and increasing. Okay, so this is the exact graph. I hope you have enjoyed this session. This was the graph. So in this way we can plot the graph of many functions in which we can differentiate and find y dash and y double dash. All right, so that's it for this session. We'll continue